The free energy principle is a fundamental concept. It explains how living systems maintain their states in a changing world. Biological systems strive to minimize free energy, an active effort essential for survival. In this context, surprise quantifies the improbability of encountering a particular sensory state. Living systems avoid surprising states, seeking predictable environments. Free energy, rooted in information theory, acts as an upper bound on surprisal. Biological systems minimize free energy to navigate existence efficiently. The principle links minimizing surprise to the emergence of consciousness. If the brain reduces free energy, consciousness might be a sophisticated manifestation of this process. It could be the brain's tool for building complex models of the world and self. These models allow for better predictions and effective minimization of surprise. This perspective bridges the gap between brain function and conscious experience. The free energy principle provides a mathematical framework for understanding life. It is a core idea in theoretical biology and neuroscience. It proposes a compelling link between minimizing surprise and subjective awareness. Consciousness might be the brain's ultimate tool for prediction. This offers a way to understand the nature of conscious experience. The principle holds profound significance for understanding consciousness. Free energy is a proxy for surprise, a quantity the brain can estimate and reduce. High free energy signals poor prediction of sensory inputs, leading to prediction error. The brain reduces this error by updating its model, perception, or acting on the world, action. This drive to minimize free energy is linked to maintaining homeostasis. By minimizing free energy, organisms maintain stability and resist disorder. The principle applies to all biological systems, from single cells to complex organisms. It provides a unifying framework for understanding adaptive behavior. Revisiting its importance for consciousness, the principle offers a compelling narrative. Consciousness might allow for deeper, more abstract models of the world. These models enable accurate predictions about future events and actions. Consciousness could be seen as an advanced strategy for minimizing surprise. It allows us to navigate an uncertain world with greater efficacy. The principle suggests a common underlying principle governs all living things. It provides a framework for understanding adaptive behavior across life. Consciousness might facilitate the creation of sophisticated models for prediction. My background in psychiatry and neuroscience led me to neuroimaging and theoretical neurobiology. I developed statistical parametric mapping, SPM, for analyzing brain activity. SPM became a standard tool in neuroimaging, mapping brain function. This work laid the foundation for the free energy principle. I sought a unifying theory to explain brain function and organization. The free energy principle emerged from understanding the brain as a self-organizing system. It integrates concepts from physics, information theory, and biology. The principle connects brain structure, computational processes, and adaptive behaviors. It offers a comprehensive framework for understanding the brain. This interdisciplinary approach is essential for tackling brain complexity. The principle aims to explain the behavior of living systems. It connects the physical structure of the brain with its function. The transition from SPM to the free energy principle was natural. SPM shows brain activity, but not why the brain functions that way. I became interested in normative theories explaining brain organization. The free energy principle aims to be a grand unifying theory for all life. It suggests minimizing free energy underpins all self-organizing systems. This principle provides a common language for diverse biological phenomena. It posits that self-organizing systems must minimize free energy to maintain equilibrium. This cycle of prediction and error correction keeps systems viable. The principle seeks to explain the nature of self-organizing systems. It offers a framework for understanding perception, learning, and action. The brain is fundamentally a prediction machine. It generates predictions about sensory inputs, flowing downwards through the brain's hierarchy. Sensory input updates these predictions, and mismatches create prediction errors. Prediction errors inform higher-level areas to adjust the model. This drives perception and learning, building rich models of the world. The brain predicts simple sensory features at lower levels and complex patterns at higher levels. Each level predicts the activity of the level below, passing errors up. This hierarchical structure allows for efficient interaction with the environment. Everyday examples include catching a ball or understanding speech in noise. The brain predicts the ball's trajectory or fills in missing sounds. These actions minimize prediction error, demonstrating the brain's predictive capacity. The predictive brain allows us to anticipate events and adapt. This architecture is essential for efficient interaction with a dynamic world. The brain's predictions enable us to navigate complex environments. Prediction error minimization is crucial for perception and learning. The brain's hierarchical structure builds multi-layered models of the world. This predictive processing is evident in many everyday situations. Consciousness plays a crucial role in managing complex predictions. It engages in novel situations, significant uncertainties, and long-time-scale predictions. Consciousness creates a coherent model of the world and our place in it. This allows for flexible, goal-directed behavior and minimizes prediction errors. Consciousness enables deep generative models, simulating future possibilities. It allows for counterfactual thinking and informed decision-making. The subjective experience of consciousness is linked to high-level model building. Accurate predictions create a sense of coherence, while errors cause confusion. Conscious thought involves generating predictions, testing them, and updating our narrative. Practical examples include the aha moment and planning complex projects. Consciousness helps us navigate uncertainty with flexibility and foresight. Consciousness involves a self-model, predicting bodily states and actions. This self-model is vital for survival and interaction. Self-awareness emerges from predicting and accounting for our states and actions. Discrepancies in the self-model lead to various experiences, drawing attention to update the model. Qualia, like pain, represent prediction errors signaling bodily harm. These experiences minimize surprise about our condition. Practical examples include hunger, motivating eating, and the sense of embodiment. Experiments like the rubber hand illusion show the dynamic nature of self-representation. The self-model is crucial for navigating existence and maintaining integrity. The free energy principle finds support in neuroscientific findings. The cerebral cortex's hierarchical organization suits predictive coding. Functional neuroimaging shows reduced brain activity for predictable stimuli. Surprising stimuli elicit stronger responses, indicating prediction error. EEG and MEG studies reveal neural oscillations, coordinating predictive processing. Computational models simulate predictive coding and free energy minimization. These models replicate perceptual phenomena and simulate learning and decision-making. Lesioned models reproduce deficits seen in neurological conditions. This provides a bridge between theory and empirical data. The free energy principle proposes that biological systems minimize free energy. This drives perception, action, and learning, with consciousness as an advanced manifestation. Consciousness involves creating sophisticated models for prediction and navigation. The principle offers a unifying framework for understanding the brain and consciousness. However, it remains a developing theory with many aspects under research. Future research will test predictions and develop realistic simulations. The principle may offer insights into mental illness and new treatment avenues. It aims to integrate brain, mind, and behavior under a single theory. If robust, it could revolutionize our understanding of consciousness and life. The journey to unravel these mysteries continues, illuminating our existence.